Alright, so today we are going to begin with the second half of surface chemistry. First half में हमने absorption, Freundlich adsorption, isotherms और ये सब चीजें हमने उसमें करी थी discuss, zeolites, catalysts, all this we had discussed in the first lecture. Now today we are going to start with the second section of surface chemistry, which includes the colloidal system. ठीक है? क्या होता है एक colloidal system? हम क्या बोलते हैं कि जैसे for example हमने सोडियम क्लोराइड ले लिया. सोडियम क्लोराइड को if we are putting it in water, what will you see? You will see one phase. You cannot see salt separately and water separately. ठीक है? Such solutions they are said to be true solutions. But if we put NaCl in benzene, we see that there are the phases, they can be differently seen. NaCl becomes something, something like jelly-like in it, and that is what a colloidal system is. So when we are talking of any colloidal system, we basically say that we are classifying the solutions into three. One is the true solutions, one is the colloids, and one is the suspensions. But when we are talking of a colloid, we say that colloid, that is not a substance, but it is a system or it is a phase of a substance, right? Just for example, we are saying there are certain elements or certain compounds which may behave as true solutions when put in one medium, or they may behave as colloids if they are put in some other medium. Okay? So that is what a colloidal system is. So when we are saying that a finally divided substances we are saying that finally divided substances of any substance lying in the range of 100 to 1000 nanometer. 1 to 1000 nanometer. This is the diameter or particle size we are talking of over here. Right? So any substance which is finally divided such that it has a particle size of 1 to 1000 nanometer, and then we disperse it in any medium. Dispersed in any medium forms a colloid. Okay? This is what is going to be a colloidal system. Right? When we are talking of colloidal systems, we say that the colloidal systems or colloidal solutions, they are intermediate between true solutions and suspensions. Okay? They are going to be intermediate between true solutions and suspensions. We say that any colloidal system consists of two phases, or in other words, a colloidal system is a two-phased system in which there is one discontinuous phase, which is known as the dispersed phase. Okay? And there is a continuous medium which is known as the dispersion medium. So basically what we are saying over here, that any colloidal solution, it is going to consist of a dispersed phase and a dispersion medium. Just as in the case of true solution, there is a solute and a solvent. Okay, so dispersed phase and a dispersion medium. Depending upon the kind of dispersed phase and dispersion medium, we classify different colloidal systems. Okay, so what are these different colloidal systems. As I just told you that these different colloidal systems, they depend upon the type of dispersed phase and dispersion medium, right? Now if we are taking dispersed phase, I am writing as dP, dispersion medium I am writing as dm, then this is the type of colloid, and we are going to do examples of each type, right? Now if we say that we are taking the dispersed phase and the dispersion medium both as gases, then that becomes a continuous system and it is not taken as an example or as a type of colloid. Okay? So if dispersed phase and dispersion medium both are gases, it is not going to make a colloid, but it is going to make a true solution. The first kind which we are going to do is, we are taking the dispersed phase as liquid and dispersion medium as gas. This is known as aerosol of liquids. Okay? And examples which we can take over here is fog, clouds, mist. All these, they are example of aerosol of liquids. The second, we are going to take solid in gas. This is how you call it also, solid in gas, right? So if we're saying solid in gas, it means that the dispersed phase is solid and the dispersion medium, that is going to be gas. Okay? This is known as aerosol of solids, right? So in both the cases you can see here the dispersion medium is gases, both they are known as aerosols. Example which we can take over here is smoke, dust. These are a few examples. Then the third one which we are going to take, that is gas in liquid. Gas in liquid. This is known as foam, right? Example which we can take over here is soap. सोप का जो फ्रॉथ होता है, ठीक है, that is going to be an example. Then whipped cream, whipped cream is also an example in this, and even the shaving foam. Shaving foam, that is also an example of this kind. Then the next one, fourth, we are going to take liquid in liquid. This is known as emulsion, right? And example, the most common example which we can take over here is oil. Milk. First take the example of milk, then emulsified oils, and also certain medicines. The liquid syrups which are given to small children, pediatric liquids, they come under this category. ठीक है? फिर उसके बाद हमारे पास आ जाता है solid in liquid. Solid in liquid, this is known as a sol. An example of sol is paints, starch in water, and also proteins. ठीक है? फिर उसके बाद the next one, sixth we are going to take is gas in solid. This is known as solid foam. An example which we can take over here is that of pumice stone, right? Pumice stone is that red color stone which is generally used to scrub feet and all the dead skin in the feet. That is this thing, right? Then another example which you can take over here is foam rubber. Foam rubber is the substance by which mattresses they are made. That is also an example of this. Okay? So if you take out the cover of the mattress, you can see inside that there are a lot of air spaces which are present. So that is gas in the solid, right? Then number 7 is liquid and solid. The kind of colloidal system that is known as gel. An example which we can take over here is cheese, jelly. All these they are examples. Butter is an example of emulsion. Okay, that is not a gel. Okay, so we have cheese, we have jelly, then we have boot polish. बूट पॉलिश एक्सेट्रा. ओके, फिर लास्ट जो हमारे पास आता है दैट इज सॉलिड इन सॉलिड and the emulsion that is known as solid sol. Examples of this is colored glass and also the gemstones. The gemstones which we wear. Okay? These are the examples. So these are the type of colloids depending upon the type of dispersed phase and dispersion medium. So if you're looking at the example, almost everything which we are using in our day-to-day life, they all are colloids. Right? Just for example, we have milk. Milk is a colloid. We have creams, we have paints, we have starch, smoke, fog, clouds, everything that is coming under colloid. So colloidal system is a very important system which has a vast study. ठीक है? In fact, इसके ऊपर एक पूरा you can see there's one full course which can be done on only colloids, specialization which is done only on this. Okay? Then after that, let's go on to the classification of the colloids. Classification of the colloids. This classification of the colloids that depends upon the forces of attraction between the dispersed phase and the dispersion medium. Okay? It is going to depend what kind of forces of attraction are present in dispersed phase and dispersion medium. On the basis of this, we classify colloids into number 1, lyophilic colloids. When we talking of lyophilic colloids, philic over here means affinity. So in lyophilic colloids, we generally say that the dispersed phase has affinity for dispersion medium, right? This kind of colloids, for example, we can talk of proteins, we can talk of starch. All these they come under this category, right? So protein, starch, rubber also. The molecules of all these systems, when we are talking of protein, starch or rubber, the molecules of all these systems, they are large sized molecules. So if they are large sized molecules, the diameter of these molecules is anything between 100 to 1000 nanometers, which come in the colloidal range. Therefore, they form the colloids. Okay? Now in this case, as I have already said that the dispersed phase has a great affinity for the dispersion medium, and if we are taking the dispersion medium as water, then they are known as hydrophilic colloids. Okay? Then they are known as hydrophilic colloids. These colloids, they are quite stable in nature because once the dispersed phase and dispersion medium, they are shaken together, they form the lyophilic colloids, and and in that case if you're trying to separate the dispersed phase from the dispersion medium, or you're trying to precipitate the dispersed phase in the dispersion medium, that is not possible in this case. So that is why we are saying that it is stable. Then thirdly, if we are evaporating the neophilic colloids, in that case what is going to happen? We are going to get a residue. Okay? Now if this residue is again put in the dispersion medium, it is going to yield back the neophilic colloid. Therefore we say that the neophilic colloid, they are reversible in nature, which means that again if we are mixing the dispersed phase and the dispersion medium, we can very easily get the colloid back. Clear? The second type of colloid which we have, they are known as neophobic colloids. The neophobic colloids, they are otherwise you can say the particles of the dispersed phase, they are small in size. In fact, they are smaller than, they do not come in the range of 1 to 1000 nanometers. So therefore they aggregate. Right? Aggregate to form clusters, or they aggregate in such a manner that the size now becomes in between 1 to 1000 nanometer. They come in between 1 to 1000 nanometer, which is a colloidal range. So the particles of the dispersed phase in case of neophobic colloids, they are going to be smaller, they get aggregated and they become closer to each other, as a result of which they make clusters, and these clusters, they come in between range of 1 to 1000 nanometers. Therefore they start making the colloids. Okay? Now in this case, the dispersed phase has no affinity for the dispersion medium. The dispersed phase has no affinity for the dispersion medium, right? And these colloids, if we put some electrolyte in it, if an electrolyte is added, the dispersed phase, they get coagulated. This we will study later. They get coagulated. Therefore, we say that these are not stable, or they are unstable in nature. They are not stable, or they are going to be unstable in nature. Okay? And also, if we are using water as the dispersion medium, then these are known as what? Hydrophobic. Okay? So they are known as hydrophobic. And once we say that if we try to evaporate the neophobic colloids, so the residue cannot be just mixed with the dispersion, dispersion medium to make the colloid again. Okay? So that is why we say that these are irreversible in nature. Okay? They are going to be irreversible in nature. So we've done two types of colloids over here. One is the neophilic and the other one, that is neophobic. Depending upon its properties, let's differentiate between the two types of colloids over here. Okay, so let's differentiate between the neophilic colloids and neophobic colloids. Neophilic and neophobic colloids. The first property according to which we are going to differentiate the two, that is the surface tension. Now in case of neophilic colloids, the surface tension is lower. Okay? ठीक है. Now it is lower to what? It is lower to that of the dispersion medium. It is lower to that of the medium. Whereas in case of leophobic, the surface tension is same as that of the medium. ठीक है. Then number 2, the second property is viscosity. Viscosity in leophilic is higher than that of the medium. ठीक है. Whereas in leophobic, it is the same as that of the medium. This is the second difference. ठीक है. Viscosity. The third difference is that the leophilic colloids, they are reversible in nature. We have just discussed this. Reversible, and this is going to be irreversible in nature. ठीक है. फिर उसके बाद this also we have already said that this is more stable, right? And this is going to be less stable. ठीक है. फिर उसके बाद number 5, particles of leophilic colloids, the dispersed phase of the leophilic colloids, the particles of the dispersed phase can't be seen, can be seen, not can't, it can be seen under ultra microscope. Whereas those of the leophobic, they can also be detected. These can be detected under ultra microscope. ठीक है. फिर उसके बाद नेक्स्ट जो हमारे पास आता है, in this case the sixth difference is that particles may migrate in any direction. What do we understand by this particular point? It means that when we are passing electric current through a leophilic colloid, the electric field has no effect on the particles, right? It is not essential over here that the particles, they are going to either migrate towards the cathode or they are going to migrate towards the anode. They do not have any specific direction. Whereas the leophobic colloids, they are very highly affected by the electric field. They are very highly affected by the electric field, which means that the particles may either direct themselves towards the cathode or they may be directed towards the anode. ठीक है. फिर उसके बाद नेक्स्ट जो आता है, in this case leophilic, addition of small electrolyte has no effect on the leophilic, which means that if you're putting up any electrolyte, that electrolyte is not going to destroy the leophilic colloids, right? But if that electrolyte is added to leophobic, a process of coagulation or precipitation occurs. Which means that if we are putting any electrolyte in a leophobic colloid, that is going to destroy the colloid. ठीक है. Leophilic colloids, they do not get destroyed. In case of lyophilic colloids, extensive hydration can take place. Extensive hydration, which means that if we are taking starch and in starch we are putting water, what will keep on happening? That will keep on getting diluted. Okay? So you can keep putting water in it, and extensive hydration that takes place in lyophilic, or in other words we can also explain this, that the process of imbibition takes place over here. What do we understand by the process of imbibition? That is swelling up in water. So when we are taking gelatin or we are taking jelly, so the crystals of gelatin or jelly, when they are put in water, they swell up, right? That is the process of imbibition. Whereas in case of lyeophobic, no hydration takes place. Hydration is not a common property of lyeophobic colloids. So this is the difference. Just go through them once again. The first one, in lyophilic colloid, the surface tension is going to be lower than that of the medium, whereas in lyeophobic it is same, right? In lyophilic, viscosity is higher. In lyeophobic, the viscosity is same. Then lyophilic are reversible, lyeophobic are irreversible. Lyophilic are more stable, lyeophobic are less stable. In this, lyophilic dispersed phase can be seen under the ultra microscope, right? Whereas there it cannot be detected. There also it can be seen, right? In this case, particles may migrate in different directions, which means they do not have much effect of electric field. If we are putting a lyophilic colloid in the electric field, the particles, they are not directed towards cathode and anode, but in case of lyeophobic, they are highly affected. ठीक है? फिर next, addition of small electrolyte अगर हम लोग डालें lyophilic में, there is going to be no effect, but on that case, the lyeophobic colloids, they get precipitated or they get destroyed. Then the last one, extensive hydration takes place in lyophilic, whereas no hydration is going to take place in lyeophobic, right? Now, these are the two types of colloids which we have done. In the next section, we are going to do types of solutions. Alright, when we are doing types of solutions, we say that the types of solutions, they are going to depend upon the particle size of the dispersed phase, right? Depending upon the particle size, we classify the solutions into true solutions, right? We classify them into colloidal solutions, and we classify them into suspensions. Right? So these are the three types. The true solutions, they are also known as molecular solutions. So we are saying that true solutions, they can also be termed as molecular solutions. The colloidal solutions, they are known as colloidal dispersions. Colloidal dispersions. And suspensions, they are known as porous suspensions. Okay? So this is how we classify them when we are differentiating between the three. In case of true solutions, the particle size that is less than 1 nanometer. Okay? Over here in colloidal solution, the particle size is anything between 1 to 1000 nanometers, and in suspensions, the particle size is greater than 1000 nanometers. Okay? Then second, we say that the true solutions, they are invisible under ultra microscope. For example, over here, we can take the example of a salt trying to see the salt particles even under ultra microscope, we will not be able to see. ठीक है? Whereas these are visible only under ultra microscope. Now over here we can take the example of milk. When we are looking at milk, what can we visualize? We can see milk as one single phase, isn't it? But we are saying that milk is a colloidal solution, which means that there are soluble fats which are dissolved in water. So water is the dispersion medium over here, and the dispersed phase, that is going to be the soluble fats. Right? So when we try to see under the ultra microscope, we can see the soluble particles, that is the fat particles inside the milk separately. Okay? Whereas in case of suspensions, we can see it under naked eye. For example, sand and water. So if you're putting sand and water, we can see the sand particles with naked eye. We do not need a microscope to see the sand particles. So that is what a suspension is. So example of true solution which we can take is sodium chloride in water or common salt in water. Colloidal solution, we can take milk. Okay? And suspensions, we can take sand in water. Then the next difference is that the true solutions, they diffuse through parchment membrane. What do we understand by parchment membrane? Parchment membrane means basically it is a membrane, cell membrane of pig. That is what a parchment membrane is. The pore size in case of parchment membrane, that is very, very small. Okay, so the true solutions, they can diffuse through parchment membrane very easily and very quickly, whereas these diffuse through parchment membrane very slowly. Okay? And in case of suspensions, there is no diffusion at all. So this is another point of difference which we can see between the three. That is true solutions, colloidal solutions and suspensions. ठीक है? फिर उसके बाद the next difference between the three is that the filtration. We say that true solutions, the particles, they pass through ordinary filter paper. As well as parchment membrane. Okay? So they pass through ordinary filter paper as well as parchment membrane. Whereas in colloidal solution, they pass through filter paper but not through parchment membrane. So over here the colloidal particles pass through filter paper but not through parchment membrane. Right? But when we are looking at suspensions over here, in case of suspensions, they neither pass through parchment membrane nor through ordinary filter paper. So we can write that the passing is impossible through both. Okay? Then there is a very, very important difference between the three. What is that? That is, in case of true solutions, there is no scattering of light takes place. Now the particle size in this case is very, very small. No scattering of light takes place. So the particle size is very, very small. They are unable to scatter light. This scattering of light, that was first observed by Tyndall. Therefore, it is known as the Tyndall effect. Okay? So the true solutions, they do not show Tyndall effect. What is Tyndall effect? Whenever we are passing a beam of light through any solution, if that beam of light is visible, that is what Tyndall effect is. Right? So when we're talking of Tyndall effect, there is a kind of the beam of light which we can see, that is known as the Tyndall cone, right? So whenever a Tyndall cone is formed by any solution, that solution is said to be showing the Tyndall effect. We will do this in detail later. Similarly, when we are talking of colloidal solutions, in this case, because the particle size is in between, so scattering of light is possible. So the colloidal solution, they show Tyndall effect. Whereas in case of suspensions, again the particle size is very large, it is unable to break the scattering of light. Therefore, suspensions do not show Tyndall effect, right? So these are the differences between the three. Now today what we are going to do is, we are going to prepare the colloids. We have two types of colloids which we have studied. One is the neophilic colloid and the second one, that is the neophobic colloids. So we are going to prepare both these colloids today, right? So let's go on to the methods of preparation of colloids. Preparation of colloids. When we are talking of neophilic colloids, in case of neophilic colloids, it is very easy to prepare the neophilic colloids. We just mix the dispersed phase and the dispersion medium, provided that the particle size of the dispersed phase should be in between 1 nanometer to 1000 nanometers. So for making neophilic colloids, because the dispersed phase has a great affinity for the dispersion medium, we simply mix them and hence the neophilic colloid that can be formed. An example which we can take over here is that of jelly, right? You know how jelly is formed. There are crystals of jelly which are readily available in the market. So you just take that jelly crystals, pour hot water in it, right? Not very hot. Say it should be less than the boiling point of water. That is that warm it should be. So we putting that water, we mixing that water with the jelly crystals. We are just stirring it continuously till all the crystals, they dissolve evenly in the entire mixture, right? And after that we refrigerate it. We do not put it in the freezer, we put it in the fridge only, in the lower compartment, and after say 3 to 4 hours we get a colloid which is a jelly. Okay, so that is the edible jelly which is generally made at home for eating. So this is what a neophilic colloid is. Even starch is a neophilic colloid. So you know when you boil rice and after that when you strain the water from it, if you keep that water for say 1 or 2 hours, you will see a jelly-like formation of starch has taken place. Okay? So neophilic colloid is easy to form. The question over here is the formation of neophobic colloids, which needs specific methods for preparation. The first method which we are going to do, they are known as dispersion methods. Okay? Now what is dispersion methods? In this case, the first kind of method which we usually use is mechanical dispersion. What do we understand by mechanical dispersion? In this, the particle size or suspension, a suspension is taken. At that suspension, it is you can say it is put into metal grinders, right? So those metal grinders, they have two rotators, one which is at the bottom and the other one which is at the top. From above we pour the suspension inside this grinder, and the movement of the upper and the lower metal disc, that is, one is moving clockwise and the other one is moving anti-clockwise. As a result of which, the particle size of the suspension, that is lowered down to the size of the colloid, right? And that colloid particle which are formed over here, they are mixed with a suitable dispersion medium in order to form the colloid. So this is what mechanical method is, right? So it's a very simple, in a similar manner as you are grinding this, wheat to make flour. It's the same method which we are using, चक्की जिसको आप बुलाते हो, ठीक है? So that is the same method which we are using over here, the mechanical suspension method. The second method which we use, that is peptization. What are we doing in this method? In peptization, we are converting a freshly prepared electrolyte into a colloid. ठीक है? So we are putting or we are converting a freshly prepared electrolyte into a colloid. How? By adding a suitable medium. This is what the process of peptization is. So peptization, basically if you define it, it is the conversion of a freshly prepared electrolyte into a colloid by adding a suitable medium. ठीक है? That is what peptization is. जैसे for example, we can say that we are taking FeCl3. Okay. Now FeCl3, that is what? A medium which we are adding to a freshly prepared solution of ferric hydroxide. Okay. Now due to the absorption of the common ions over here, you can see that this has FeCl3, this also has Fe as a common ion. So what is going to happen over here? The size of FeOH3 is very small. So the ions, Fe3 positive ions which are present in ferric chloride, they are going to be selectively absorbed on the surface of ferric hydroxide. ठीक है? They are going to be selectively absorbed, as a result of which the particle size of ferric hydroxide that increases and comes in the range of the colloidal particle. Okay, so the colloid that is formed, this is known as the selective adsorption method. Have you understood? So peptization क्या हो रहा है कि we are taking a freshly prepared electrolyte, उसके अंदर हम लोग एक कोई ऐसा solution डाल रहे हैं which has common ions. These common ions, they are getting selectively adsorbed on the surface and hence the size that is becoming in the range of the colloidal particle size. ठीक है? ओके, फिर उसके बाद एक और मेथड हम यूज करते हैं which is known as the Pradeep arc method. In case of Pradeep arc method, we take a trough which has a lot of ice. This is the ice bath, and inside that we immerse a beaker. ठीक है? In the beaker there is, say, we are taking water over here. In this water we are dipping metal electrodes like this, and these metal electrodes, they are attached to a high voltage of battery, right? Then a current is passed through these electrodes at a very high voltage, at such a high voltage that these metal electrodes, they start melting. ठीक है? When they will melt, the temperature of water is very low, as a result of which they will immediately precipitate or they will immediately form plastic kind of a colloid, right? Now why it is known as Pradeep's arc method? This process that was given by Pradeep, the scientist Pradeep, so after his name, arc over here is that as soon as a very high voltage that is applied on these electrodes, an electric arc can be seen at this point. So that is why this method that is known as Pradeep's arc method. ठीक है? Clear हो गया? फिर उसके बाद the next method, the second type of method which we are going to use, they are the chemical methods. These were the dispersion methods. Second method of preparation is the chemical methods. Chemical methods, they are generally used to prepare liophobic colloids. ठीक है? So chemical in nature. They are not physical. Okay, so they are all chemical substances, as a result of which we use chemical methods. For example, if we want to make a colloid of arsenic sulfide, in this case we react arsenic oxide with enormous water, okay? Sorry, not with water, with hydrogen sulfide. When we get a cold solution of arsenic sulfide, okay? So this is going to behave as a colloid, right? Then after that, if we want to prepare a colloid of ferric hydroxide, in this case we take freshly prepared ferric chloride and we react it with water in order to get a colloid of ferric oxide, okay? And we are getting HCl. Right? So over here, all these, they are prepared by chemical methods. Right? Then there are a number of metals. You can write down number of metals like silver, gold and platinum are obtained by reducing aqueous solutions of their salts. Aqueous solutions of their salts. ठीक है? So this is another method. फिर उसके बाद a colloidal solution of sulfur, if you want to prepare, it can be prepared by the oxidation of H2S to give us a sol of sulfur. This is a sol of sulfur which is prepared over here. ठीक है? Then if a solution of sulfur in alcohol is added to water, what will happen? We've taken sulfur in alcohol and we add it to water. In that case also a colloid of sulfur can be formed. Right? So these are a few methods of preparation. This is all what we are going to do today. Now tomorrow we are going to do the purification of the colloids which we have made. Right? Today, whatever we have prepared today, tomorrow we are going to purify these colloids. The various methods like which you also use in biology, that is dialysis and electrodialysis, all that we are going to discuss tomorrow. In these methods, the principal differences between the colloids and the true solutions, that is kept in mind in order to purify the colloids. Basically what is happening is that all these colloids which we have formed today, they all have impurities in the form of crystalloids. Right? Crystalloids are electrolytes which are present. So these electrolytes, they have to be separated from the colloids so as to get pure colloids. Okay? So in the next lecture we are going to do that. Okay?